Hello and welcome to the beginning of Chapter 5. For Chapter 5, we're going to give you the sheet that's going to help you out with different bases to certain powers, and on the back, there's all sorts of properties of exponents. Okay. It's a good idea to have this paper out with you, all right, so you can refer to it at different points. All right. On the front of the page, you notice there's all of our perfect squares over here to the left. All right, just a reminder, if we wanted to write this as a radical, and let's just say we want to say 36 equals 6 squared, well, the square root of 36 is 6. All right, so just understand that. To use the examples for the cubes here, I don't know, I'll do 7. So the cube root of 343 is 7. So just understand how we can kind of refer to this chart. All right, if you look down at the bottom, there's some 4th powers, 5th powers, and 6th powers. Same thing, the 4th root of 81 is 3. All right, I don't know, let's do the 5th root of 3,125 is 5. Obviously, I'm referring to the different roots here, okay, just so you understand how to use this. So you should have the sheet pretty ready for you, or pretty readily, all right, as we go through Chapter 5 so we can see the different roots and powers and different things like that. On the back is some properties of exponents that we'll get into later in this chapter, but it's good to have it now. You won't need to remember the exact rule, like the name of it. You just will need to know how to actually use it. Okay, so now on to Chapter 5. All right, just a reminder, make sure you have that sheet out when you're going through. It's a nice little helpful sheet. All right, so beginning this chapter, we're going to start off by talking about the nth root of a. All right, so the way we look at it is if we said if b to the n equals a, then b is the nth root of a. Okay, so that's pretty much what I just talked about before. All right, so if we said, I don't know, 5 to the second equals 25, right, then b is the nth root of a. So basically it's saying the square root of 25 equals 5. All right, then b is the nth root of a. That's kind of what's going through there. All right, the next term we're going to start off by defining is the index of a radical. All right, I'm going to basically simplify here. The index of a radical is what root to take. All right, for the most part, we've only dealt with square roots. Understand there is a 2 here. All right, so if I looked at it and I said, I don't know, the square root of 5, all right, the index is 2. There's an implied 2 here. We just never really write it, all right, but just understand that that's really there. All right, if we said the cube root of 7, the index is 3. And if I don't know, I just said the 5th root of 12, the index is 5. So basically, if you think about it, it's what root we're taking, all right, which is going to be the number inside of the radical, all right, check mark part of it. All right, I don't know if that just made it worse, but you can see those numbers there. All right, so the next part just talks about some real nth roots. Okay, it's very important to understand here. We want this to be a real number. All right, so we're not going to deal with imaginary numbers in this case. All right, so as we go through, all right, we'll notice if n is an even integer and what numbers inside the radical is less than 0, there are no real nth roots. All right, I know it kind of goes back and forth different times. All right, but what we need to understand is if they ever ask us for real numbers and the number is less than 0 inside the radical, we would say no real roots. All right, if the number inside the radical is 0, like the square root of 0, we would have 1 real nth root. All right, and if it's greater than 0, we will have 2 real nth roots. All right, so basically what it's saying is if we take the nth root of a, it's going to be plus or minus a, all right, to the 1 over n. All right, but we're going to have 2 answers here. So when it's even, notice, if it's less than 0, no real roots. If it is 0, 1, If it's greater than 0, 2. Okay, that's for any time we're taking an even root. 2, 4, 6, 8, so on and so forth. All right. When it comes to n being an odd integer, so we're talking about cube roots, fifth roots, seventh roots, ninth roots, so on and so forth. All right. There's only ever going to be one real nth root. All right, because think about it. If we want to take something to the third power, the number now can be a negative. So if we said the nth root of a, it's just really a to the 1 over n. All right, I'll make this a 1 so you can see it, so nothing there. Same thing for all of these. There's going to be one real nth root, and then once again, one real nth root. All right. So anytime it's an even integer, we can have none, 1, or 2. Anytime it's an odd integer, so now we're talking about odd roots, there's only ever one solution. Okay. So as we look at the bottom here, all right, we go through. The n is the exponent, the a is the number inside. All right. For the most part, we're going to stick to basically saying anytime we take an even root, we're going to say 2 answers. The book jumps back and forth, but let's just make sure we're all on the same page. That will always just say, if it's an even root, we should have 2 answers. All right. So the n is the index. So what root we're taking? So we're taking the 4th root of 16. Okay. So if I look at my helpful paper here, well, 16, we're talking about 4th roots. That would be 2. So our answer here would be plus or minus 2. Okay. For the next one, we want to do the 2nd root of 16, which is the square root. You can write it like that, or you can write it like we've been doing for as long as you have. Just the square root. There's an implied 2 there. Square root of 16 is 4. All right. For example C, they want the cube root of negative 125. All right, so if we look at our paper again, just to kind of show you to get the habit here, these are the cube roots, okay? Well, where's 125? It's right here. Well, that's going to be 5 to the 3rd. So this will be 5, but it's really negative 5. If you think about it, negative 5 times negative 5 times negative 5 is going to be 25 times negative 5, which is negative 125, just to show you. There's still our one root here. All right. Okay, on to the next page. There's a couple more examples of these. All right, we want to go with the 5th root of 32. So the index is odd, so we'll only have one answer. It'll just be 2. All right. The cube root of negative 216, we look at our sheet again, it would be negative 6. Okay, all you're doing here is just looking at your sheet. The n is the index, so what root you're taking, all right, and the a is the number inside, the radical, all right. And our last one here is the square root of negative 49, all right. They asked us for real roots here, so this one here would be no real roots. All right, I understand we have gone through and solved for imaginary numbers, but it's really important you look at the directions, all right, to see what they have here. Okay. So rational exponents. Rational exponents basically means we're now going to have a fraction as an exponent. There's something that I find really helpful here. When we go through and do this, when we have a fractional or a rational exponent, this should be numerator, sorry. The numerator is the power that we're going to raise the number to, all right? The denominator is the root we're going to take, all right? I always just remember it because if we think about it, roots go in the ground, that's on the bottom. All right, so they give us 2 examples here, a to the m over n. So what this is really saying is a to the 1 over n all to the m power. Okay. Another way we could write that, to see it a different way, is this is really also saying, these are similar, the nth root of a all to the mth power. Okay, and this is going to have, you'll see some examples to kind of show you why we want to do this. All right. Now the tricky part here is, remember when we have negative exponents, we can't have negative exponents, we need to make them positive. All right, so when we have negative 1 over m to the, or a to the negative m over n, all right, we need to bring that down to the denominator. So this will really be 1 over a to the m over n. All right, just to show you example again, just because if we look down here, all right, on our back of our helpful sheet, rules of exponents, negative exponents, that's how we work with them. It'll be this example here, we bring it to the denominator. Okay, it's a very helpful sheet that we need to make sure we have here. All right. So if that's the case there, we can go through and realize we can do the same thing we did the other part, except now it's all in the denominator. All right, and this can kind of help us. These two are the same as 1 over the nth root of a all to m. And just remember that a cannot be 0 here. All right. You're probably like, what is going on with this? Don't worry, we're going to practice it. You'll see it. It'll make a lot more sense. Okay. Oh, look at that. Some examples right here. All right. So when we have this, they want us to evaluate these without a calculator. If they tell you without a calculator, just understand there's probably a good idea that the number is going to be a whole number or an integer here. It's not, we're not going to have some type of decimal. All right, so when we look at the first one, it's saying 16 to the 3 halves. All right, if I remember about my rule up here, the numerator is the power, the denominator is the root, I can really rewrite this as the square root of 16 all to the 3rd power. Okay, well, why would that help me? Well, what's the square root of 16? Remember, said we're always going to do plus or minus. It would be plus or minus 4 to the 3rd power. And now we'd have to do 4 times 4 is 16, times 4 is 64. So our answer here is plus or minus 64, because we could do the same thing. Negative 4 times negative 4 is 16, times negative 4 is negative 64. All right, just try to remember to always, anytime you take an even root, to keep the plus or minus there. All right, the next one we have is 64 to the 4/3. So the root we're taking here is the cube root of 64 all to the 4th power. All right, well, if we look at our sheet again, the cube root of 64 is 4. All right, and we're going to raise that to the 4th power. All right, and we can look at the sheet for that as well, and that will be 256. Okay. Our first negative exponent here. So with our first negative exponent, we need to make it positive. So we're going to bring the whole thing down to the denominator, which will turn the exponent positive. All right. So now if we want to work with this one here, it's going to say we're taking the 4th root of 16, and then we're going to raise it to the 5th power. Well, the 4th root of 16 is plus or minus 2. And we're going to raise that to the 5th power. 2 to the 5th is really plus or minus 1 over 32. All right, and these all come from our sheet here. All right, you're taking the 4th root of 16, which is plus or minus 2. You're raising plus or minus 2 to the 5th power. We have plus or minus 1 over 32. All right. For example D, we have another negative exponent, so we need to change it to be 1 over 9 to the 1/2 power. All right. Big hint here, if you ever have 1/2 power or 1/3 power, the 1/2 power is saying the square root, the 1/3 power is saying the cube root, okay? So this will really be 1 over the square root of 9, and just to show you, that would be to the 1st power to keep our pattern going here. Well, what's the square root of 9? It's 3. So we would say plus or minus 1/3. right? Because if we raise 3 to the 1 power, it's still 3. Okay. For E, we want 81 to the 3/4 power. So this is going to say the root we're taking is 4. So we're taking the 4th root of 81. So I'll rewrite that so you can make sure you can see it. All right, we're taking the 4th root of 81, and we're going to raise that to the 3rd power. All right, make sure you pay attention to this root because it's the 4th. So this is going to say it should be plus or minus 3. All right, and then we'd raise plus or minus 3 to the 3rd power, which would be plus or minus 27. Please remember, anytime you take an even root, you need to make sure you have plus or minus here. Notice that's why you have plus and minus for most of these, but not for example B, because we're taking the cube root, which is an odd root. All right. And F, which is 1 to the 7th eighths. So that's going to be the 8th root of 1 to the 7th power. Well, the 8th root of 1 is plus or minus 1 to the 7th power. All right, which is plus or minus 1. All right. So those are some without a calculator. Okay, so if they ask without a calculator, we're probably going to be getting integer answers. All right. There are some times when they're going to ask us to use a graphing calculator or a calculator to do this. All right. Just understand they're going to tell you how many decimal places to round, so make sure you pay attention to that as well. All right. And I'm just going to show you on my calculator real quick a couple important things here. If you want to take 12 and raise it to the 3/8, you're going to do 12, the caret. I like to do parentheses 3 divided by 8. Okay. It's important you put the exponent to in parentheses so we'll evaluate it correctly. So we have 2.539, right? They want 2 decimal places, and we're taking an even root here, so this would be plus or minus 2.54. Just some, notation I use. I always underline this number here to say that that number has been rounded up, okay? And the reason obviously it's rounded up is if we look here, it's 2.539, so that 9 would round that 3 up to a 4, okay? We would do the same thing for the next one. It would be 7 caret, parentheses, 1 divided by 4, close parentheses, and we would get all right, just to show you again, 1.626, which would tell us it's 1.63, and that 3 has been rounded up. All right, same thing with the next one as we go through it. We would do 64 caret, negative 2 divided by 3. All right, so we would get 0.06. Notice we're taking the cube root here. All right, so when we take the cube root, we only need one answer. All right. I'll just go through and give you the next ones, the same thing here. I'll show you anyways. So now when we want to take the cube root, all right, there's a couple different ways you can do it. The easiest way to do it is go to math and go down here and look at number 4. It's the cube root of 11. Get your answer and then square it. So this would be 4.95. Okay. On some of your calculators, depending what you have, you might need, when you're taking the cube root, you might need to put a 3 and then go down to the one with the x root, and now it'll say the cube root. And if you really wanted to, you can even square it here and you'll get the same thing, okay? So just make sure you're careful how you write these things. All right. The next one is the cube root of negative 30 squared. This will be 9.65. All right. And the last one we have is the 4th root of 16 to the 5th power. All right. That will be plus or minus 32. Okay. Because remember, now we're taking an even root. We're doing that. same thing just to show you. We want the 4th root, so we do 4 math, go down to the x root of 16, and then we want to hit the caret and raise that to the 5th power, so it'll be 32. Notice your calculator doesn't give you plus or minus. That's something that we need to know, okay? If you do not have a TI-84, you need to make sure you work on understand how to input these values, all right? If you have any questions, obviously, please feel free to reach out to us. All right, last 2 examples. We're gonna go through and solve some of these, all right? So when we solve these, it's the same thing with any type of solving. We wanna get the x by itself first. So for example A, we're gonna divide each side by 5. So we'll get x to the 3rd equals 64, all right? Well, how do we undo a 3rd power? We take the cube root. It's the same thing. How do we undo something squared? We take the square root, all right? Those will cancel out, and it'll give us x equals 4. So that's our answer, because the cube root of 64 is 4, all right? Even when we have something to an exponent, like in example B, we have x plus 3 all to the 4th power. Okay, when we do this, I'm just gonna rewrite this step to kind of show you so it doesn't get jumbled in there. What we're gonna do to get rid of the 4th power is we're gonna take the 4th root of each side. The 4th root to the 4th power will cancel out, so that'll give us x plus 3 equals the 4th root of 27. Okay. Well, we don't know the 4th root of 27, all right? And just to show you that we don't, I'll just go through and show you we really don't. All right, it's this kind of, crazy decimal that we get here. All right, irrational number, if you will. But what we would do is now we'd subtract our 3 from each side. Oh, what did I forget here? I forgot the plus or minus. All right, because we're taking an even root. All right, so we have x equals -3 plus or minus the 4th root of 27. All right, just something to understand here. If we ever ask you for an exact answer, this right here is your exact answer. All right, that means it hasn't been rounded or anything like that. All right, if you were going to ask, like, get round to 2 decimal places, all right, if we asked you to do that, all you would do here is just type this in. You would say -3 plus the 4th root of 27, all right, and that would give you x equals -0.72, and then you would do -3 minus the 4th root of 27, which would be x equals -5.28, all right, and that would be rounded because it's 5.279, all right. So just a couple things to understand. Exact answer is with the radical. If they ask you to round, you would obviously use this bottom piece and just round that to 2 decimal places. All right, that's today's video. Your homework will be posted shortly. If you have any questions, please let us know. Have a great day.